Hello students, today we are going to start our new topic. The name of topic is circle. That is our chapter number 10. As you know, the chapter number 9 is not in our syllabus. So after completion of chapter number 8, that is quadrilateral, we are going to start today onwards chapter number 10. Okay, so first of all, in the chapter number 10, as you know, the name of the chapter is circle. So circle, there are many terms which are associated with the circles. For example, up till now, you know some basic things. For example, radius, diameter. Okay, but now in this chapter, we shall learn some more definitions, some more terms which will be required to be used in the questions of the chapter. Okay, so first of all, we shall start from the beginning. What is circle? So circle, you can see the definition is written in front of you. The collection of all points in a plane which are at a fixed distance from a fixed point in the plane. You can see the figure. Okay, one figure is in front of you. That figure is made up sorry, the figure is made up by some tiny dots. Okay, and if I take one dot and if I take the center, means we can take one fixed point at the middle of the figure, then that point name I am giving as O. So O to A, if I calculate this length, and same way if I change the point from A to B, and again if I calculate the length from O to B, and in the similar way O to C. So this is called as the fixed distance, and this fixed distance will come always same. Okay, so if this distance is coming same of all such points like A, B and C, and there may be infinite other points over there. So when we will join this all such points, it will form a curve that is called as the circle. Okay, as you can see here that there are many points over there. So suppose here if I take one more point D and if I join O to D, okay, similarly if I take here sorry, one more point E, and again if I join O to E, suppose here if I take one more point and if I join O to F, then O to D, O to E and O to F, they all will be having the same distance as compared to O to A, means OA, OB and OC. Okay, so circle definition is this: all such points when you will join, the figure formed will be called as the circle, and the condition behind that is the length from center to any point on the circumference will be, the length will be same. Okay, now let us see the second definition. The second definition is given here as radius of circle. So see, in the circle definition we have seen the condition is the length of O to A, O to B, O to C, etc. will be same. But this fixed distance, now we shall give a name. The name is radius. Okay, so here OA, OB, OC and the other length I have taken here, that all will be called as the radius. So now radius, how we can define clearly here? Here O will be called as the center of the circle because it is coming in exactly in the middle of the figure. So O will be called as the center of the circle, and A, B, C, D, E, whatever the points I have taken, that is called as the points on the circumference of the circle. Circumference means at the boundary of the figure. Okay, so here we can say that the radius definition is the length between center to any point on the circumference. Center to any point on the circumference. It can be A, it can be B, or it can be any other point. Okay, as you can see, we have written here the above figure OA, OB, OC, all are called as the radius of circle. Okay, now let us move to the next definition. Before to move the next definition, we shall see one remark. So see here one remark we have written. That remark will be useful in solving the questions of 10.1. So see, in this remark it is written over there, a circle divides the plane on which it lies into three parts. They are inside the circle, which is also called as the interior of circle. Second one, the circle. The circle we should not write. I think it is should be written on the circle. On the circle. And third one is outside the circle. Means suppose, what is plane actually? Plane is a rectilinear figure. You can suppose as a rectangle. Okay, Now suppose that we have one rectangle. You can see that blue rectangle figure you can consider. Okay, on that if you keep the circle, then circle is dividing the rectangle into three parts basically. One part which is coming inside the circle, you can see this white portion I am talking about. Okay, so this white portion is actually the part of rectangle, but now since circle is overlapping, so we can say that it is a common part between both of them. So this one part the circle has made on rectangle. Second one, you are looking some blue portion which is coming outside the circle. Okay, so the plane has, this is the second part, as a blue shade over there. So this will be coming as an exterior of the circle. So this will be our second part. Okay, I will write down here, this is second part, this is first part. Means first part means this whole white portion we are talking about. This white portion will be called as the first part made by the circle. Okay, and this blue portion you are looking over there, this blue portion if I represent by the dot, this portion is another one part of the rectangle which is coming exterior of the circle. So this will be the second part. Okay, and what about the third part over here? The third part is on the circle. You look at the boundary of the circle. Okay, this boundary of the circle is actually the third part of the third part which is made by the circle on the rectangle or the plane. Okay, so we can say that, see, this boundary actually doesn't come inside the circle or it doesn't come outside the circle. So boundary will be the separate part, that is very thin part, very small part, or it can be easily ignored. But if we see it carefully, then the two parts we can easily identify. One is outside the circle, one is inside the circle. But one more part is there which is on the circle, that is on its boundary. So if anybody asks if the circle divides the plane into some parts, then how many parts can be there? So your answer will be three parts it will be there. One is inside the circle, second one is outside the circle, and the third one is on the circle. On the circle means on its boundary. Okay, suppose anybody is standing exactly on the border of India and Pakistan. So can we say that it is in India, or we cannot say that it is in Pakistan also, because it is standing on the boundary. That is our third part over here. Okay, now let us start the third definition. Now we will see the third definition, that is chord and diameter of the circle. So what is exactly chord and diameter? Now see, chord first of all we shall define. Suppose if I take 2 points on the circumference of circle, okay, say A and B. You can see the figure, the point A, sorry, I will take a point P and Q first. Suppose if I take a point P and point Q, you are looking in the figure, point P and Q both are coming onto the circumference of circle. Now if these 2 points I join and form a line, then this line will be called as the chord of a circle. The chord of a circle is nothing, it joins 2 points lies on the circumference of circle. Circumference, I hope now it is clear to you. Circumference is nothing, it is a boundary of the circle. Okay, so point P and Q both are lies on the circumference, and if you join both of them, the line forms is called as the chord of a circle. Remember, point P and Q should lie onto the circumference of circle. They should not lie outside the circle, they should not lie inside the circle. Okay, now what is diameter? Diameter is actually a chord, but it passes through the center. You can see clearly the chord PQ doesn't pass through the center O, while the chord AB passes through the center. So diameter is nothing other than the chord. Only the difference is the diameter is that kind of chord which is passing through the center of the circle. And second thing, diameter will be the longest chord of a circle. You can see in the remark, okay, we have written over there, diameter is the longest chord. Why it is the longest chord? Because when it is passing from the center, the length will be maximum in that case. You can see clearly the PQ is looking much shorter than the chord AB. Okay, so remember, when it is passing through the center, it will have the longest length. Okay, So one thing, diameter is the longest chord of the circle. Second thing, diameter is 2 times the radius. How we can say? Observe, we have defined the radius is the distance between center and any point on the circumference of circle. So from here we can say that OA and OB both are radius. Okay. So OA and OB, now 2 times radius is coming in the diameter AB, and hence we can say that yes, it is 2 times of the radius. So that also you remember, diameter is 2 times the radius of the circle. Now let us see the fourth definition, that is called as the arc of a circle. Now these definitions are little bit complicated. Okay, so see, arc of a circle, a piece of a circle circumference between 2 points is called as an arc. Look at the pieces of the circle between the points P and Q. See, first of all, see the points P and Q. Now if I consider this length, okay, I am not taking the line over here. You observe, if this length of the circumference, if I take from P to Q, okay, suppose if I take this length from P to Q, but I am taking the part of the circle circumference, or you can say that the part of the circle boundary. So this part is called as the arc of a circle. Okay, this is called as an arc, nothing else. Arc is a part of the circle circumference. Okay, that is one definition. Second thing, we can say the arc can be of two types. One is a major arc and second one is a minor arc. Definition is written in this manner. The arc which is looking shorter one is called as the minor arc, and the arc which is looking the major one is called as the major arc. But I don't think this definition is 100% accurate. I will show you what exactly the minor arc is. Suppose if this a circle we have given. Okay, suppose this is a circle, and if I say, sorry, I will draw it once again. Yes. Okay, this is a center O, and if I take here 2 points P and Q. Okay, and if I say PQ is the arc of the circle. Okay, you will observe P and Q. If I take this length, then PQ will be the arc of the circle. Now we have to decide whether the arc PQ is major arc, okay, or it is a minor arc, or another kind of arc it is. There can be three types of arc can be possible. So see, you need to join O to P and join O to Q, and then measure the value of the angle POQ. Okay, the value of the angle POQ, suppose it comes here 60 degree, means it comes below 180 degree, then it will be called as the minor arc, means the value of the arc decided by the arc makes the angle at the center. Here we can say that the arc is making the angle at the center. The name of the angle is angle POQ. How we can decide the value over here? You need to see whether that angle is an acute or obtuse maybe, but below 180 degree, that easily you can observe. If that angle is below 180 degree, it will be called as the minor arc. Okay, second thing, if the value of the angle is equal to 180 degree, then it is called as the semicircular arc. Okay, semicircular arc. And if it is more than 180 degree, then it is called as the major arc. So remember the difference about the major, minor and semicircular arc. Below 180 it is minor, more than 180 it is major, and equal to 180 means it is semicircular arc. Now let us see the remark number 3. Yes, in remark number 3, see what is written there. The minor arc PQ is also denoted by the symbol given to us. See the symbol, this symbol I am talking about. Okay, sometime we write down the arc PQ by this symbol also. Okay, and major arc, we write down the full name PRQ, means the between P and Q, whichever the point is coming, that point also we write down, and we make a symbol of arc over there on its top. So nothing else. If you don't want to use this symbol, you can simply write down the arc PQ over there, or you can write down the major arc PQ or minor arc PQ. That word also can be written. Okay, and see here one more thing is written there: unless otherwise stated, RPQ stands for the minor arc PQ when P and Q are, where R is the some point on the arc between P and Q. Unless otherwise stated, arc PQ stand for minor arc PQ. Okay, so until and unless they given to us, we will assume it is a minor arc. Okay, otherwise it is clearly told to you, yes, arc is a major arc. Okay, so suppose in the question you may get confused, the arc is minor or major, or the values are not mentioned. So in that case, if nothing is mentioned, we shall take it as a minor arc. Otherwise, they will mention you as a major arc in the question. Okay, and one more thing is written there: when P and Q are the ends of a diameter, then both arcs are equal and each is called as the semicircular arc. That already I have told you, because in the semicircular arc what will happen, the points P and Q, suppose this is the point P, if I say, and this will be a point Q, and this will be a point O. Okay, so PQ is the arc. So if PQ arc is semicircular, or we can say that it is having the value 180 degree, then angle POQ will be here of 180 degree. Okay, then we'll say that it is a major arc. Second thing, you observe the line point P and Q are the end points of diameter. So if the point P and Q are the end points of diameter, it will become definitely a semicircular arc, because in that case the value of angle POQ is equal to 180 degree. Okay, now let us move to the next definition, that is segment of a circle. Segment of a circle is nothing. See, if you draw one chord in the circle, okay, so it will divide your circle into two parts. One part you are looking the blue shade over there, and second part you are looking the white shade over there. These are called as the segment of a circle. Properly, how we can define? The region between the chord of a circle and the arc of a circle. Observe. See, this is PQ. PQ is your chord over here, right? PQ is a chord, and observe PQ, P to Q. If I go in this way, then this will be the arc of a circle. So the region between them, this region, if I talk about, so this region is called as the one of the segment. As you can see here, the region we have mentioned, this is a minor segment. Okay, so this region is a minor segment. Why it is called as the minor segment? Because you see, the major part is coming here, and here somewhere the center will lie. Definitely in this minor segment the center will not lie. Center will lie in the blue part over there. So wherever the center lies, that segment is called as the major segment, and wherever the blue center doesn't lies over there is called as the minor segment. Okay, so segment, basically what actually segment is, where the region we see between the chord and the arc of a circle, that is called as the segment, and in whichever the segment the center lies, that is called as the major segment, and in whichever the segment center doesn't lies is called as the minor segment. Let us move to the last definition of today's sector of a circle. The region between two radii and arc of a circle is called as the sector of a circle. Sector, see, if you may have remembered the sector of the circle with some very good examples, like a piece of the cake. When you cut the cake, then it looks like the blue shade you are looking over here is exactly is one of the piece of the cake, or the pizza you may have seen, the person cuts the pizza into various sector only. So here sector is what actually? It is a region between two radii. You can see PO and OQ are the two radii, and the third one is the arc of the circle. The three things makes a sector of the circle. Okay. And second thing, again two sectors are there. One is major sector and second one is minor sector. So what is the major sector and minor sector? If the two radii and the minor arc of the circle is making the sector, that sector will be minor sector. And if the two radii and the major arc of the circle, you can see here, this is P to Q. If I go from here, then this place and then again come back to Q. Okay, somewhere like this. So this will be the major arc. Okay, so if the major arc and the two radii of the circle makes the sector, that sector will be major sector over there. Okay, again here one remark is written, remark number 4. When two radii and a semicircular arcs form sector, then it is called as the semicircular region. Means suppose that the arc is a semicircle, okay, and then two radii are there, then that sector will be called as the semicircular region. Now let us start the our questions of exercise 10.1. So first question we are seeing 10.1 is a very simple exercise. Fill in the blanks and true false are only given over here. So let us start first of all with the fill in the blanks. Okay, first fill in the blanks is given over here. The center of a circle lies in dash of the circle. You can see, suppose if I draw one circle over here and if I ask you center, where does it lies? Inside the circle or outside the circle? So you will say definitely it lies inside the circle. Okay, so here answer we shall write down. We will write down the answer, interior of the circle. Okay, then similarly a point whose distance from the center of a circle is greater than its radius lies in dash of the circle. Means they are saying, suppose there is a circle, okay, and in this circle suppose we have given that one point P and here we have given that point O as a center, and if I take here point Q on the circumference of the circle. Now you observe here OQ is clearly called as the radius of the circle, one thing, and if I join O to P, then you observe the point P lies outside the circle, so its length is greater than the radius of the circle. So now tell me the point P whose length will be greater than the radius, where does it lies? Definitely it will lie outside the circle, because if the point P lies inside the circle, it will be smaller than the radius, and if it lies on the circumference, it will be equal to the radius. So if its length is more than the radius, definitely it would be lying outside the circle. So here answer we will write down exterior. Okay, the next one is the longest chord of a circle is a diameter of the circle. So here we will write down longest chord of a circle is diameter of the circle, that you knows very well. Okay, the next one is an arc is a dash when its when its ends are the ends of a diameter. So see, suppose they are saying the type of the arc, means they are asking the arc will be a minor arc, or it will be a major arc, or it will be a semicircular arc. So you know that if its end points are the end points of diameter, okay, observe this kind of arc, what it will be called? If point P and Q are the end points of diameter, then this kind of arc will be definitely called the semicircular arc, because now this arc will not be the minor arc or it will not be the major arc. Okay, so here we will say that an arc is a semicircular arc when its ends are the ends of a diameter. Segment of a circle is the region between an arc and dash of the circle. Remember what definition I have told you segment? Suppose if this is a circle, okay, and if I draw one chord over here and if I take one arc over here like this, okay, so this is the region between chord and arc, and this is called as the segment of a circle. So segment is what exactly? The region between chord and the arc of a circle. So here already arc is given to us, okay, so here we shall mention chord of the circle, arc and chord, right? Last one is a circle divides the plane on which it lies in three parts. You can refer, if you want, you can refer the remark number 1 again. See, just now I have explained to you. So please refer the remark number 1 for the three parts, how it is possible. One is interior, one is exterior, and one on the boundary of the circle. Okay, so three parts can be there. Now let us see the true false. See, the first true false is given over here. Line segment joining the center to any point on the circle is radius of the circle. Line segment joining the center to any point on the circle. On the circle means on the circumference of circle. They are talking about here. Is a radius of the circle? Yes, true, because by the definition of the radius. Here we can say true by definition of radius. Definition of radius, we can say that this is, what is the definition of radius? The distance between or the length between the center of the circle and any point on the circumference of circle is called as the radius of circle. So this statement is true. Now, what is second one given to us? A circle has only finite number of equal chords. Observe, this is a circle we have given to us. Okay, and if I say join any 2 points on the circle circumference and form the chord over here. Okay, so suppose here one point A I have taken and here B I have taken the second point. Now observe, I have taken A and B point out of how many points available on the circumference of circle. On the circumference of circle, you see there will be infinite number of points are available. From our eyes we cannot observe all the points, but technically we can say the infinite number of points are available, and hence if you join any 2 points with the out of the infinite number of points, you will draw one chord over there. So each and every time you can select the another sphere of the points, and hence you can form the infinite number of chords because you have available options are infinite number of points. So you can say that there will be infinite number of chords could be possible. So how we shall write down the answer over here? We'll write down false. First of all, the statement is false. We'll say since circle is drawn with the help of infinite number of points, infinite number of points, and hence we can draw infinite number of chords. Okay, because since points are only available infinite, so why we cannot draw the infinite number of chords? Okay, I will write down this answer again in a systematic manner, and then I will give it to you over there so you can keep it properly. Okay, you can write down in your notebook also. Third point is given here. The third question is if a circle is divided into three equal arcs, each is a major arc. See, I have explained you what is the definition of major, minor and a semicircular arc. So suppose that if a circle we are dividing into three equal arcs. Okay, suppose this is a circle, and if I take here 3 points P, here if I take Q, and here if I take R. Okay, so if I say the PR, QR and PQ, all three are equal. So it means that when we shall take the angle at the center by the arc PR or by the arc QR or by the arc PQ, all these three angles will come same, because if the arcs are same, definitely they will make the angle at the center will be also same. So here if this angle I take it x, this angle is also taken at x, and this also if I take it x. So see, all the three angles are forming the complete angle. Okay, means their sum will be equal to 360 degree. So if I solve it, so this will be 3x will be equal to 360, and value of x will be coming here 120 degree. Right, now you observe the value of x is coming 120 degree, means the value of each and every arc is coming 120 degree. And we know that if the value of each and every arc is below 180 degree, that arc is called as the minor arc, and here they are asking major arc. Okay, so here we can say that the statement will be false. Okay, I will write down the statement properly and listen along with that, so you can see it afterwards. Now quickly we shall finish the part number 4, and one more part is there, part number 5. A chord of a circle which is twice as long as its radius is a diameter of the circle. Yes, definitely the reason will be true, because they are talking a chord. The chord which is twice as long as its radius is called as the diameter of the circle. We know it, the definition only says the diameter is twice the radius. So if any chord which is twice the radius, definitely it will be a diameter of the circle, and hence it will be passing through the center also. And see, the one or two more parts are remaining over here. Sector is the region between the chord and the corresponding arc. See, sector is what actually? Suppose this is a circle. Okay, and here if I take a center, and if I draw two radii over here, so the region between two radii and the arc of the circle is called as the sector. Okay, but what they are giving to us, sector is the region between chord and the corresponding arc. The region between chord and corresponding arc is a segment. Okay, and that is not a sector, so this statement will be false. Right, and the last one is circle is a plane figure. Circle is a plane figure, that is true. Why we can say it is a plane figure? Because it is a two-dimensional figure. When you draw the two-dimensional figure, you require two dimensions. So see, when you are plotting the circle, then on that time you require a two-dimensional plane, then only you can draw the circle on the two-dimensional plane. So we can say that yes, circle is a plane figure because it is a two-dimensional figure. Okay, so I have just roughly explained you this all true and false. This systematically I will write down, and then we can see how we can describe the reason behind that. Reason I have told you orally over here. Okay, next time we can start the exercise 10.2 onwards. Thank you.